Alright, everybody. Well, yesterday we learned how to deal with one-step equations and how to solve those. And the way we did it was by using these ideas of inverse operations. That was how we did it. Using subtraction to cancel out addition, or to undo addition. Using subtraction to undo addition. Using multiplication to undo division. Using division to undo multiplication. We had these ideas from yesterday. And we're going to bring those back today when we solve two-step equations, but things are going to work a little bit differently as well. We have a few things to talk about there. We're going to use something that's going to end up being really, really helpful to us, called the Who chart. So it'll have this H and this U kind of in a chart form. What do the H and the U stand for, though? Well, we don't really have a volunteer bundling up with winter gear, but imagine someone standing there and then putting on their winter gear. So they put on, snow pants possibly. So, and let's think about the order in which they might put these things on. So they might put on the pants first, so snow pants. So what's happening is they have their snow pants and they're putting them on. And then next, maybe they'll take their coat and they'll put their winter coat on. After that, we've got the pants, we've got the coat on. It would be time probably for some boots. So we're going to take our boots and we're going to put those on. And of course, we don't want our hands to get cold. So we may put gloves on at that point. And we could put other things on like a scarf or a hat. That would come a little bit later, but we're not going to worry too much about that. Well, the way it's going to work here in these problems is we put these things on in this order: pants, then coat, then boots, then gloves. What's going to happen is we are going to then, we have to take this winter stuff off so that we're comfortable again, but we're going to do it in the reverse order. So we put our gloves on last. We're actually going to take our gloves off first, because otherwise it's kind of hard for us to manipulate getting everything else off, right? Especially if they're mittens, where they don't have fingers. So gloves off first. Then we'll probably take our boots off. Possibly our coat, I suppose, but we're going to not do that. We're going to take our boots off next. We certainly will have trouble taking the pants off if we don't take the boots off first. Take our coat off next. And then finally, we would take the snow pants off. So you can see that we put things on in a certain order, and then we take them off in reverse. It's going to work the same way for our math. To put a few words onto what's happening here, you can actually fill this in the section before the last one in the notes. The H section basically stands for what's happening, whereas the U part stands for how do I undo it. So H is happening and U is undo. How do I undo it? So let's look at how this applies to math a little bit. If we have one variable and no order of operations, it's not that bad. It's not that hard. So here we have our variable. And what's happening to that variable is we have two things. We see that the variable is multiplying by 2, and we also see that to the variable we are adding 6. Now, I want you to think about that. Following order of operations, which of those is happening first? Well, PEMDAS tells us that the multiplication is happening first. So I'm going to put times 2 here, and I'm going to then follow it up with the plus 6. I'm following order of operations on the H side. So times 2 followed by plus 6. And then we need to think about how we're going to undo that. And the order in which we're going to do things to undo it is we're going to go from the bottom up. So how do I undo plus 6? Well, the opposite of plus 6 is minus 6. So the first thing we're going to do is we're going to subtract 6 from both sides. And then how do I undo times 2? Well, the inverse operation of times 2 is divided by 2. So I'm going to divide by 2, and that'll be my second step. Then I should have my answer. So let's see how that plays out in the actual problem. So if I start with 2x plus 6, and my first step is to subtract 6, I'm going to do that here. And of course, since this is an equation, I need to do it on both sides. The plus 6 and the minus 6 will cancel out, or will undo each other, I should say, and turn into 0, leaving us just with 2x on that side. And then negative 10 minus 6 is negative 16. So we've taken care of subtracting 6. We need to do our second step now and divide by 2. So I divide by 2 here, and I divide by 2 here. And these will turn into 1 when they undo each other. 1 times x is just x. And then on the other side, we have negative 16 divided by 2, which is negative 8. Checking our answer is really simple. All we have to do is, we got this value of negative 8. We just plug it in to the original, and we see if it gives us something that's true. So let me erase a little bit of this work. So we're going to plug this into 2x plus 6 and see if we get negative 10. Our value is negative 8, so does 2 times negative 8 plus 6 equal negative 10? Well, 2 times negative 8 is negative 16 plus 6. Negative 16 plus 6 is negative 10. So, yes, we got the answer right. If you didn't end up getting negative 10, which is what we had here on the other side, then something went wrong. Let's see a few more examples. All right. So here on this one, first let's find that variable, and we'll think about what's happening to that variable. Two things again. One, we have this 2 here, but really if you look at it, it's actually a negative 2. And that negative 2 is multiplying the variable. And then we have this 4 here. What is this 4 doing? Well, it's a positive 4. It's certainly not multiplying the x. Since it's a positive 4 that's just sort of sitting there, we could describe it as being added onto the variable. Even though there's no addition sign with it, it's still being added on because it's a positive 4. Remember, addition is commutative. We could move it to afterwards. So we could also write this as negative 2x plus 4. And then it would be easier to see that that is, in fact, a 4 being added. So on our h side, we're going to put those into PEMDAS order, which they actually already are. So we have times negative 2 happening, and we also have plus 4 happening. And then we're going to have to undo those. And we're going to go in backwards order like we did last time. The inverse operation for plus 4 is minus 4. So there's that. And the inverse operation for times negative 2 is divided by negative 2. So that's what we need to happen over here in our problem. And let's see it unfold. So first thing we're going to do, remember we always start down here, so that's step 1, that's step 2. So we're going to subtract 4 from both sides. Minus 4, minus 4. Remember that both sides are determined by where the equal sign is. So we just need to minus 4 on one side of the equals and the other side. So on this side we have 18 minus 4. 18 minus 4 is 14. And on this side, the 4 and the negative 4 undo each other, become 0. 0 minus 2x is just negative 2x. And our second step that we identified was we need to divide by negative 2. So I'm going to do that. Divide by negative 2, divide by negative 2. Be careful with the signs here. Negative 2 divided by negative 2, those undo each other and both become 1s. We have 1 times x, which is just x. And on the other side, 14 divided by negative 2, well, if it was 14 divided by 2, it would be 7, but it's negative 2. So it's going to be not 7, but negative 7. Again, not too hard to check our answer, so let's just take a moment of time. to do that, all we have to do is plug it in to the equation. So we have 18 equals 4 minus 2 times, and we got negative 7 as our answer. So that would be 4 minus negative 14. Well, 4 minus negative 14 is the same as 4 plus 14, which does end up being 18. So it worked. That's our answer. We got it correct. So I circle it, and we are good to move on. That may be one of the trickiest examples that we have. You'll be happy to know. All right. Moving right along, then. Moving right along. Here we have 1 equals negative 8 minus 3x. What do we have going on with the variable? We have two things again. We have this times negative 3 happening, and we also have a minus 8. Order of operations, we're just going to rewrite that again here in our WHO chart. How do we undo minus 8? Well, we're going to do plus 8. How do we undo times negative 3? We're going to divide by negative 3. So, let's see that in action. To undo the negative 8, we do plus 8 plus 8. 1 plus 8 is 9. The 8 and the negative 8 will undo each other, leaving us with negative 3x. Our second step was to divide by negative 3. So we divide this side by negative 3 and this side by negative 3. 9 divided by negative 3 is negative 3. And the negative 3's are going to undo each other there, leaving you with 1 times x, which is just x. So the answer there ends up being negative 3. I'm not going to go through the checks anymore, but I think it's a good thing for you to do if you're unsure of your answer. A few more examples. Here we have p divided by 9 minus 15 equals negative 6. Here's our variable. What's happening to it? Well, we're dividing by 9, and we are also subtracting 15 then. So order of operations has us write the division first, and then the subtraction. Undoing those, we're going to go in the backwards order. To get rid of the plus or the minus 15, we're going to do plus 15. And to get rid of dividing by 9, we're going to multiply by 9. So let's see that play out in the example then. First thing we're going to do is add 15 to both sides. These 15s, the negative and positive, will undo each other. Negative 6 plus 15 is 9. So now we're left with p divided by 9 equals 9. Our second step is to multiply both sides by 9. These 9's are going to cancel out, since one is multiplying and one is dividing. These 9's are going to multiply, as is there. So we're going to have 9 times 9 is 81. And p is left alone. It's really 1p, but 1p is just p. So I'm going to write that. Done. That one is finished. Last example we're going to go through right now, and then we'll talk about the challenge one tomorrow in class. In this one, here's our variable. We have two things happening, and we need to, again, kind of be careful about the order. Remember that when you have a fraction, the numerator and denominator are kind of in their own. Never mind. So we have 8 plus x over 7. So what's happening? Well, the x is dividing by 7, and also we're adding 8 to the x. I should not have drawn those parentheses in, because they don't exist there. That's not part of the problem. All right. So, divide by 7. Oh, wait. I'm noticing something. We do need the parentheses. We do need to treat the top, the numerator, as one thing, 8 plus x. It needs to stick together, because it's the numerator. It needs to stick together. So, if you're looking at order of operations here, normally we would put the division first. But here, because the 8 plus x is in the numerator together, we actually need to put the plus 8 first. That's what's happening first, and in this one case. And then we're dividing by 7. So to undo this, we're going to have to do times 7 first, and then minus 8. That one's a little bit tricky in that way. So let's see how that plays out here then. First thing we're going to do is multiply by 7. Multiply by 7. When we do that, 7 times 5, negative 5 is negative 35. And on this side, the 7's undo each other, leaving us with 8 plus x. Now we have to get rid of that 8, and we'll do it by doing minus 8 minus 8. We get negative 43 on this side. These 8's undo each other, leaving with x. So there we have it. Negative 43 equals x. So that's how you solve these two-step equations. We will come back to that challenge problem a little bit later. For now, you can see the assignment at the bottom of your note sheet. I suppose if you don't have a note sheet, let me also put that up here on the board. There it is. So your homework is right there. Workbook page 32, numbers 1 through 3, 7 through 9, 13 through 15, and 20. So, thanks for watching. Good luck on the homework. Come back with any questions that you have, please.